Oxygen makes ozone. Oxygen, and we'll talk about this a little later, looks like this. It's two oxygens, and they're double bound to each other. And we'll be talking about rules in the bonding unit, how oxygen only gets two bonds, and it can't have less than two, and it can't have more than two. But ozone is super weird because ozone actually looks like this. Ozone has 1.5 bonds, not 2. Okay. And that's a very, what is right? What just happened? That's okay. You're going to be even more frustrated when we get to the bonding unit. So oxygen can bond with itself 3 times? Yeah, okay. And that's because of something called resonance. It's a very complicated term to explain that sometimes in chemistry, if something's stable, it's allowed to happen. So on one side, you have a double bond, and the other side, you have more. They're called valence electrons. We'll talk about them later. But you could also say the double bond is on the right side and the electrons are on the left. So what that means is that in nature, it's actually an average of left and right bonding. So we show that as a dotted line to show that sometimes there's an extra line on one side and sometimes there's an extra line on the other. Okay. Now that's not important for this unit, but if you ever see it, if you're ever Googling ozone and it shows this and you're like, what is happening? It's called resonance. All right. So what you do have to know is how ozone is created. Okay. Ozone has to be made from oxygen that exists. And oxygen is basically fruit ninja'd in half by UV light into something called free radical oxygen. Do you remember how like a week ago I told you guys oxygen is always O2? Well, that's a lie. Oxygen can just be O, but you have to put a dot on it. It's free radical oxygen. It's very unstable, and it's looking for another oxygen that looks like itself to bond with to make a complete pair. And what happens is the free radical oxygen will find itself some normal oxygen, say, how you doing? And they make ozone. Okay. This is very hot. This reaction of how ozone is created is very hot. All right? Most of that energy doesn't come back down to Earth. So this has nothing to do with the greenhouse gas effect. Ozone is high in the atmosphere, and when this energy is released, it goes out to outer space. Now, why is ozone so important for life on Earth? Okay, if we can make ozone, what happens? Well, energy that would normally probably overwhelm our Earth, UV light, and on the electromagnetic spectrum, now this is it. See if I can get out of here. Dots, okay, perfect. On the electromagnetic spectrum, you have radio waves, you have microwaves, you have visible light, then you have ultraviolet light, you have X-rays, gamma rays, over here you have cosmic rays. So, speaking of this, you remember people, maybe some of your parents who are conspiracy theorists are talking about 5G and how it's causing COVID-19. 5G is like right here. Also, all the other Gs are in that same spectrum. So there's actually more energy from your computer screen than from 5G towers. So it's like this crazy conspiracy theory. Anyways, ultraviolet light is bombarding us all the time from the sun. But the ozone takes a huge chunk of that out because ozone, when it gets hit by this ultraviolet light, busts up into free radical oxygen and oxygen itself. And then guess what happens? That free radical oxygen finds oxygen again and makes more ozone. So this is like the cycle of keeping us alive. You have all of these things in this cycle, right? this process should just continue on and on and on and on and on. So why is this part of environmental chemistry? Oh yeah. Okay, so this is oxygen, and then we have ultraviolet light, and then free radical oxygen. Oh, I bet you weren't expecting that. Okay, moving on. All right. Okay, so these reactions are kind of confusing. So instead of me having to write them out, I'm just going to leave them up there for you so you can just come back and look at them, right? So ozone can be destroyed naturally by other stuff. Okay, it can be destroyed by other stuff. Oxides of nitrogen that we've already talked about, made from car exhaust, can actually destroy ozone and make even worse oxides of nitrogen. Like nitrogen trioxide is hella dangerous. Now, this can occur naturally. Remember, we talked about how nitrogen oxides and sulfur oxides can be made by nature. However, humans can also make this by car exhaust, okay, burning fuels. The big one that's the big problem is something called chlorofluorocarbons. Chlorofluorocarbons. A chlorofluorocarbon looks like this. You have a carbon, and attached to it you have 2 chlorines and 2 fluorines. That's what chlorofluorocarbon looks like. If you want to see a picture of it, you'd have this is your carbon, and then you'd have a chlorine. Chlorine's really big, actually. Then you'd have a chlorine, and then you'd have a smaller fluorine. Okay. So chlorofluorocarbons were created by chemists as a coolant and a propellant used in fridges, air conditioners, like hairspray. They were great for the consumer purpose that they were invented for. But they had a horrific, unintended consequence. And here's how it goes. It is kind of confusing. Okay. When light, any kind of light, hits a chlorofluorocarbon compound, it excites the compound and creates something that is even more dangerous than free radical oxygen. Free radical oxygen actually would kill us if we were surrounded by it. It makes free radical chlorine. So think about where chlorine is on the periodic table and how it's a halogen and how halogens are hella dangerous. Think of something that's hella dangerous, even more hella dangerous. Crazy dangerous. Now, what that chlorine molecule does is it finds, and it will, through random chance, find an ozone molecule and rip the ozone apart. It will steal the extra oxygen that the ozone has and make this very unstable compound, ClO. And the problem is that ClO, if it gets hit by any free radical oxygen in the atmosphere, which remember there is as ozone breaks down, it will make free radical chlorine again. And you can see why this is such a disastrous reaction, is that the chlorine free radical just cycles. Then it can go back and bust up more ozone. So instead of this molecule here sometimes combining with oxygen to make ozone, the chlorine free radical system is keeping it out of the loop of making ozone. And chlorine free radical is just decimating the ozone molecule. This was a massive issue. And scientists first realized there was a problem in the 70s. This took 15 years for the ozone layer to be depleted as much as what they think 25% in 10 years. Humans took away this gas that had been built up in our atmosphere for millions of years. And something was done about it. It was called the Paris Accord, so it was in Quebec. I think it was the Montreal Accord, and nations agreed to stop using chlorofluorocarbons. Okay, so what destroys ozone? Okay. So builds a molecule with 2 chlorines and 2 fluorines. Yeah, that's right. If a chlorine gets out, it wrecks everything. Okay, so why is the loss of ozone such a bad deal? Well, first off, it directly affects plant life. Now, plants aren't the most exciting thing, but you can imagine how long we would last without plants. Ozone destroys extra UV light destroys chlorophyll. You think, oh, don't plants eat light? Well, they do, but too much of a good thing is bad for them. Also, zooplankton, which is basically the food product of it's like the bottom of the food chain in the ocean. It kills zooplankton. And in humans, lack of ozone leads to increased UV and skin cancer. It's really bad for us. Depending on how dark your skin is, you've got built-in sunblock, right? So if you are Polish like me and you're so white, your skin is like pale blue, you're like a Smurf, then you're affected more. You have less natural defense against UV, right? So those of you who have ancestors that evolved closer to the equator, you have darker skin. You have built-in, I guess, sunblock. You've got so you know what? You don't have to worry too much about the ozone layer if it ever gets destroyed. But the super pale Smurfy people like me, especially those of you guys out there with red hair who are Smurfs with red hair, you're even more in danger of getting killed by this. So it's bad. Eventually it would reach levels that would be dangerous for people with really, really dark skin. And the superpower of having that extra sunblock built into their skin. Okay, so just remember, that's plankton is actually a zooplankton, and zooplankton under the microscope, they actually look like this. There's a Banfield marine biology trip that was supposed to go this year, but was shut down because of the apocalypse. And when you look at zooplankton under the microscope, that's what they look like. They do look like plankton. And the irony is that plankton's wife is a computer, and she feeds him holographic food, which is actually light. And planktons are photosynthetic creatures, so he is actually eating the right type of food, which is from light. Okay. So what were CFCs used for? I kind of talked about it. They were coolants and solvents, and they were propellants. That's what they're used for. And they're outlawed most of the places around the world. And there are some alternatives, which I'm going to run through really quick. Now, all of the alternatives come with also unintended consequences. So butene is a good alternative because it doesn't break down ozone, but it's flammable and toxic. So if your house starts on fire, your fridge is now a bomb if it's full of butene. Okay? Okay, another really good one that most places use is tetrachloromethane. It's not explosive, but we haven't had it for long enough to know what extreme long-term things of it does to the human body. Looks promising, like it's not going to cause any problems. And another explosive one is fluoro ethane and fluorosilane. So these are other alternatives. They're really good. They don't wreck the ozone, but again, they're very expensive to make. So fluoroethane is a common propellant. It just costs more. And there are some countries that like to keep using CFCs, but because so few countries use it, we've done a better job of protecting our ozone layer. Okay, I'm going to have a couple links in the lesson for this that you guys can look at. And some of them are kind of funny. Okay, that is the ozone layer.